Good afternoon, everyone. I'm Cyril Joyce Corpus, Group 6. Today, we're going to discuss the test of normality. Here at test of normality, the chi-squared goodness of fit test can be used to test a variable to see if it is normally distributed. The null hypotheses are the variable is normally distributed. The alternative hypothesis is the variable is not normally distributed. If the observed frequencies are close in the value to the expected frequencies, the chi-squared test value will be small and the null hypothesis cannot be rejected. If there is a large difference between the observed frequencies and the expected frequencies, the chi-squared test value will be larger and the null hypothesis can be rejected. So now, here, the test of normality, we're going to use chi-squared to determine if the variable shown in the frequency distribution is normally distributed. We use A alpha is equal to 0.05. So for our boundaries, 89.5 to 104.5 is the frequency is 24. For 104.5 to 119.5, the frequency is 62. For 119.5 to 134.5, the frequency is 72. For 134.5 to 149.5, the frequency is 26. For 149.5 to 164.5, the frequency is 12. For 164.5 to 179.5, the frequency is 4. The summation of the frequency is 200. First, for our solution, first find the mean and the standard deviation of the variable. Then, find the area under the standard normal distribution using the z-value and table E for each class. Find the expected frequencies for each class by multiplying the area by 200. Finally, find the chi-squared test value by using the formula. So our formula for our chi-squared is equal to the summation of observed value minus expected value raised to 2 all over the expected value. Now, for our next step, since our boundaries, so we have frequencies and boundaries. Now we're going to find the midpoint. So midpoint is upper limit plus lower limit all over 2. So 89.5 rather, minus 104.5 all over 2 is equal to 97. 104.5 plus 119.5 all over 2 is equal to 112. 119.5 plus 134.5 all over 2 is equal to 127. For 134.5 plus 149.5 all over 2 is equal to 142. For 149.5 plus 164.5 all over 2 is equal to 157. And 164.5 plus 179.5 all over 2 is equal to 172. Now, we're going to find the frequency multiplied by midpoint. So for 89.5 to 104.5, our frequency is 24 and our midpoint is 97. Therefore, 24 multiplied by 97 is equal to 2,328. For our 104.5 to 119.5, our frequency is 62 multiplied by 112 is equal to 6,944. For 119.5 to 134.5, our frequency is 72 multiplied by 127 is equal to 9,144. For 134.5 to 149.5, our frequency is 26 multiplied by 142 is equal to 3,692. For 149.5 to 164.5, our frequency is 12 multiplied by 157 is equal to 1,884. For 164.5 to 179.5, our frequency is 4 multiplied by 172 is equal to 688. The summation of frequency multiplied by midpoint is equal to 24,680. And now for our next step, we're going to find the frequency times the midpoint squared. So let's focus for our frequency and midpoint. So we have 24 times 97 squared is equal to 225,816. So for our frequency 62 multiplied by 112 squared is equal to 777,728. For frequency 72 multiplied by 127 squared is equal to 1,161,288. For frequency 26 multiplied by 142 squared is equal to 524,264. So 12 multiplied by 157 squared is equal to 295,788. And 4 multiplied by 172 squared is equal to 118,366. And the summation of the frequency multiplied by midpoint squared is equal to 3,103,220. And now, for the sample mean. So the sample mean is equal to the summation of frequency multiplied by midpoint all over the summation of frequency. So the summation of frequency times midpoint is 24,680 all over the summation of frequency. So 24,680 all over 200 is 123.4. So our standard deviation is equal to square root of the summation of frequency multiplied by the summation of frequency times midpoint squared minus the summation of frequency multiplied by midpoints raised to 2 all over the summation of frequency multiplied by the summation of frequency minus 1. So therefore we have the summation of frequency, which is 200, multiplied by the summation of frequency times midpoint squared, which is 3,103,220, minus the frequency, the summation of frequency times multiplied by midpoint is 24,680 raised to 2 all over summation of frequency multiplied by the summation of frequency minus 1, which is 200 multiplied by 199. Therefore, our standard deviation is 17.03. And now, the area to the left of x is equal to 104.5 is found as, so our z is equal to x minus x bar all over s is 104.5 minus 123.4 all over 17.03 is equal to negative 1.11. In table E, negative 1.11 is 0.1335. Next, the area between 104.5 and 119.5 is found as 119.5 minus 123.4 all over 17.03 is equal to negative 0.23. In table E, negative 0.23 is 0.4090. So the area of Z is greater than negative 1.11 and less than negative 0.23 is 0.4090 minus 0.1335 is equal to 0.222755. Next, the area between 119.5 and 134.5 is found as 134.5 minus 123.4 all over 17.03 is equal to 0.65. In table E, 0.65 is 0.7422. So the area for Z is greater than negative 0.23 and less than 0.65 is 0.7422 minus 0.4090 is equal to 0.3332. Next, the area between 134.5 and 149.5 is found as 149.5 minus 123.4 all over 17.03 is equal to 1.53. Using table E, 1.53 is 0.9370. For the Z is greater than 0.65 and less than 1.53 is 0.9370 minus 0.7422 is equal to 0.1948. The area between 149.5 and 164.5 is found as 164.5 minus 123.4 all over 17.03 is equal to 2.41. Using in table E, 2.41 is 0.9920. So the area for Z is greater than 1.553 and less than 2.41 is 0.9920 minus 0.9370 is equal to 0.0550. So the area to the right of X is equal to 164.5 is found as 164.5 minus 123.4 all over 17.03 is equal to 2.41. So again, using table E or in table E, 2.41 is equal to 0.9920. So the area is 1.0000 minus 0.9920 is equal to 0.0080. Now, the expected frequency are found by 0.1335 times 200 is equal to 26.7. 0.2755 multiplied by 200 is equal to 55.1. 0.3332 multiplied by 200 is equal to 66.64. 0.1948 multiplied by 200 is equal to 38.96. 0.0550 multiplied by 200 is equal to 11. 0.0080 multiplied by 200 is equal to 1.6. Note, since the expected frequency for the last category is less than 5, which is 1.6, it can be combined with the previous category. So the x squared is found by, so we have here the observed value and the expected value. Now, use the formula for chi-squared, which is equal to the summation of observed value minus expected value raised to 2 all over expected value. So chi-squared is equal to 24 minus 26.7 squared all over 26.7 plus 62 minus 55.1 squared all over 55.1 plus 72 minus 66.64 squared all over 66.64 plus 26 minus 38.96 squared all over 38.96 plus 16 minus 12.6 squared all over 12.6. So our chi-squared is equal to 6.797. So the critical value with the degree of freedom is equal to 4 and the alpha is equal to 0.05 is 9.488. So the null hypothesis is not rejected. Hence, the distribution can be considered approximately normal.